Hello bachcho. So the question is, an equilateral prism deviates a ray through 45 degree for two angle of incidence differing by 20 degree. Okay. So the refractive index of the prism is okay. So we are given a equilateral prism. So the angle of prism A will be equal to 60 degree, and the deviation is given as, the delta is given as 45 degree, and the another thing that is given as that the two angle of incidence is differed by 20 degrees. So I1 minus I2, let's say these are the two angle of incidence, these differs by 20 degree. So you know the formula of deviation. The deviation delta is equals to I1 plus I2 minus A. So you can write I1 plus I2 equals to delta plus A, that is 105 degree. So from here you can calculate I1 and I2. So adding both this equation 1 and this equation 2, will get I1 plus I2 equals to 105. So on adding these I2 got cancelled, and we'll get 2I1 equals to 125 degree. So from here we can calculate I1 equals to 62.5, and putting the value of I1 in equation 1, we'll get I2 equals to 42.5 degree. Okay, so we have find I1 and I2. See, if the angle of incidence, this is coming like this, and then it will deviate. So these angles are R1 and R2, and you know that R1 plus R2 is equals to the angle of prism, that is A. Okay, so R1 plus R2 is equals to 60 degree. So from here you can write R2 as 60 degree minus R1. Now we'll apply the Snell's law, okay, for finding the refractive index of prism. So applying the Snell's law, so this medium is air and we are moving it into the glass medium. So we can write it as mu of air, that is 1. So the refractive index of air is 1. So 1 into sine I1, and this will be equal to what? The refractive index of prism, that is mu times sine of R1. This is equation number 3rd. Okay, and again writing the equation for this, will get mu into sine R2, and this will be equal to 1 into sine I2. This will be equation 4. So putting the value of R2 in this equation, that is 60 minus R1. Okay, and now for both the equation, the value of the refractive index will be equal. So we can equate the equation 3rd and the equation 4. Okay, so sine I1 upon sine R1 will be equal to sine I2 upon sine R2, and R2 is equal to what? We can write 60 minus R1 in place of R2. Okay, so we know I1, we know I2, we have to find R1. So from solving this equation, we'll find R1 as 34.31 degree. Use calculator to find this, okay? You don't know these type of conversion. So R1 equals to 34.31 degrees. So from here we can directly find the refractive index, that is mu equals to sine I1 upon sine R1, and R1 is 34.31 degree and I1 is what? We can write in place of I1 62.5 degree. Okay, so from here the refractive index is 1.567. So option number A is the correct answer. Thank you.